because when they say you just have a triangle, you have to assume it's not a right triangle. So they do give us some information. They give us that side A is 510. So we're going to check these off as we go. Side B is, let's see, 650. And side C is 221. And they want us to find specifically angle A. So that is our hint, is we've got three sides. When you've got three sides, you know you've got to use the law of cosines. However, I need to use the law of cosines that has us finding angle A. Well, the law of cosines that has us finding angle A means it's going to also start with side A. So the formula we're going to use is the one that starts with side A. So we'll start out with the A squared equals, remember it starts looking like the Pythagorean theorem, the other two sides squared and added up, minus 2 times, now it starts looking a tiny bit like the Pythagorean theorem, minus 2 times the two sides, B and C. And then we have our cosine part and our angle that we're looking for. In this one, they wanted angle A. Remember, this is how I always remember the formulas. They wanted us to find angle A, so I need to be starting out with side A. That's how these formulas work. And the other two sides, the B and the C, are always along with the angle on the other side. So we've got the C and the B to fill in. Okay, so let's go ahead and color code and fill in everything that we've got. Now notice we do have side A, which is 510. Remember, our sides are squared because it's very similar to the Pythagorean theorem, although it's not the Pythagorean theorem because it's not a right triangle. It's the law of cosines. And then we've got B, which is 650. So we'll plug that in, which is again squared, plus C, which is 221, minus your 2 times, getting there, times what first? B, which was 650, times C, which is 221. And we don't know A, so we're going to leave the rest alone. So that last part will just stay as cosine of A. That will not get filled in because that's what we're looking for. We're trying to figure out what A is. So how do we solve this? Well, we still have to follow the order of operations as a reminder, which means we need to do exponents first. So we'll start off by doing our exponents first, which means we'll start off by doing our 510 squared and our 650 squared and our, oops, forgot the 2 on the 221. The 221 was squared as well. So let's go ahead and start by doing that. So our 510 squared would give us, let's see, would give us 260,100 equals, now we can do our 650 squared, which would give us 422,500 for our 650 squared. And then we have plus our 221 squared, which is, let's see, 221 times another 221, that's what it means to be squared, is 48,841. And we're getting there. The next thing that you could do is go ahead, because we're moving left or right, that's okay to do, is to go ahead and multiply out what's out in front of our cosine. But be careful, it is attached to our cosine. So we've got minus, and let's do our multiplication here. We've got 2 times 650 times 221. So that's 2 times 650 times 221 is 287,300, and that'll be out in front and attached to our cosine of A. We still have to follow order of operations here with what our next steps are. So the goal here is we need to get this cosine piece by itself first before we can do anything. So let's see how we're going to do that. So let's take a look at what we've got. So far we've got 260,100, and then we've got 422,500. We've got our 48,841. And we've got our minus now, 287,300. That's attached to our cosine of A, and that's what we're trying to get by itself. So if we're trying to do that, first of all, we need to get everything else on the other side. So let's move, first of all, the 422,500. That's a positive, so we will subtract 422,500 from both sides to get rid of it and move it to the other side. But that's not all we have to move. We also have to move, let's see what else, the 48,841, which is also positive, so we'll move that by also subtracting 48,841 from both sides, so 48,841. So that gets rid of both numbers, and let's see what that gives us when we're all said and done. So let's see. Let's use our calculator. We will still have, no matter what, on the other side, we'll still have the negative 287,300 in the cosine of A. At least it's by itself now. The question is what happens when we subtract our 260,100 minus our 422,500 and minus our 48,841. What we get when we subtract all those values is a negative 211,241. Now the last thing that we can do is divide both sides by what's in front of the cosine here to get the cosine by itself. So we'll divide both sides by a negative 287,300. Notice we're dividing because it's actually multiplied by or attached to the cosine. So what we would do next is remember that a negative divided by a negative is a positive, so those two negatives will cancel. However, I really wouldn't do much with the fraction. We don't want to round or anything. It'll throw off our answers until the very last moment. So let's keep going along. So now what we have is 211,241 over our 287,300 and our cosine of A. So the next part, what we'll do is we'll get rid of the cosine on the right-hand side by doing what? We'll do inverse cosine on both sides, because that's how you get rid of a cosine. Don't forget your parentheses when you do this little step. So what that is going to tell us is the inverse cosine and cosine will cancel out, leaving you with just the angle A. And so we've got inverse cosine of that really big fraction, the 211,241 over 287,300. Now what's nice about this is a scientific calculator can do this and a graphing calculator can do this, so this could be on either section to the test. The question is, we have to go back to the original problem and ask, do they want this in radians or degrees? And they say round your angles to the nearest tenth, round lengths to the nearest tenth, and angles to the nearest degree. So they do want this in degrees, so we'd go to our calculator and make sure that we are in degree mode when we actually do this problem. So we'd go use our calculator. So we'd go use our calculator. And we'd be looking at it in degree mode. So let's go ahead and do that. I get an angle A of 42 degrees, 0.67 degrees. However, my MATLAB would mark this wrong because you were asked to round to the nearest degree. So rounding to the nearest degree means taking that 2 and looking behind it. Well, remember that anything 5 or greater should be rounding up, so this is going to round up to 43 degrees. So we've got our angle A that they were asking for using our law of cosines.